circles, ellipses, and now hyperbolas. You will have met hyperbolas in Year 11 math methods, Unit 1 and 2 math methods. The simple form y equals 1 over x, where you get an asymptote, and the reasons behind that asymptote. We'll now move on to a slightly different type of hyperbola, but it's still one with asymptotes and equations that we need to consider. Our general form again sets up very similar to what we've done with circles and ellipses. You'll notice the one difference here is we've got a negative sign, so x squared over a squared, this time minus y squared on b squared. And again, we're fixing it to be 1 on the right hand side. So if we need to do a bit of algebraic manipulation, as we did with ellipses, we're trying to get 1 on the right hand side of that equation. Looks a bit complex to start with, but much of the same properties that we've dealt with circles and ellipses will come into play here. We'll start with the basic form, and then we'll look at some sort of translations. Again, similar to what we've been talking before with circles and ellipses. So here we have two parts of the graph. The positive part here, the blue line over here, with an x-intercept of a0, and the negative part here with an x-intercept of minus a0. And you can see this a value is created from this a squared term on the bottom of this particular part of the equation. So we've got a centre before any translations of 0, 0, just the origin there. Our two asymptotes will actually intersect that centre, so the centre is not actually a point on the graph, just like with circles and ellipses, the centre is not a point on the graph, it's just a reference point. And then we'll move out to these points a0 and minus a0, and they'll be known as our vertices. So if you think of those as some sort of horizontal turning point, I guess to speak, that's what our key points there will be when we have to come to graph these, a0 and minus a0. These happen to be our x-intercepts, however we may have some sort of translation, so if we need to find any intercepts, same technique we've been looking at before, let x equal 0 to find a y-intercept, let y equal 0 to find an x-intercept, nothing changes. Our asymptotes are probably the trickiest part of this particular part. We won't look at the derivation. I think your textbook has a nice proof for a derivation of where these come from. We'll get two asymptotes, and again they'll meet at the centre, and the equations of those will be y equals b on ax for our positive gradient, and y equals negative b on ax. So our b on a values are picked up from the original equation, not forgetting to take the square root, and quite often you'll end up with surds in those particular forms as well. And they get a little bit messy when you look at the translations as well. So basic form, centre, x-intercepts, any y-intercepts, asymptotes and vertices, and then we'll look at the translations. So our translations set up very similar to what we've dealt with before. Same basic equation, this time with a negative sign between. X minus h is going to cause a shift to h, and y minus k will cause a shift to a value of k, a y value of k. So we'll get a new centre, a new intersection point of our two asymptotes of h, k. Now asymptotes become, as I mentioned before, just a little bit tricky. If we look at this translated form here, our x minus h gets substituted into the asymptote, and our y minus k gets substituted into the asymptote. However, we like to write our asymptotes in the form y equals, so we'll look at taking this k value, whatever numerical value it might be, taking it across to the right hand side. You can now start to see this y equals mx plus c type of form evolve. A little bit of work to do here. I'd suggest in terms of remembering a formula or actually using a base formula, this is probably the correct form to use. I wouldn't be trying to memorise an expanded form of that. Either take this form or that form in your basic notes, and then adopt those as you need, as you've got the values of a and b to substitute in. So we won't go through the process of drawing one, we'll save that for an activity in class. They are reasonably complex to draw, but the properties are no more difficult than the circles and ellipses work that we've been doing. Key points are obviously your centre, your vertices, so don't forget to label those points. Your intercepts, which come from these particular equations, and you'll need all your good linear graphing skills. Your asymptote equation, so any equation here must be labelled. Okay, don't forget to label the equations of those asymptotes. And one last thing to touch on is asymptotic behaviour. Examiners will be really harsh on graphs that are not carefully drawn with asymptotic behaviour. So by that we mean this blue line is approaching the asymptote. Okay, I'll give you an example over here that may be a little bit iffy. We've got an example over here. This blue line is starting to edge away from that particular line. You want to be really careful with your graphs that you're showing asymptotic behaviour. So this blue line needs to approach the green line, not touch, not cross, but certainly not deviate away. So that's what's meant by asymptotic behaviour. That covers the base forms. A lot of the course in specialists will question your understanding of these particular concepts and give you new graphs that you may not be familiar with. What type of graph? Well, there's a large variety of graphs, but this will be one alternative form that you'll see quite often with hyperbolas. Subtle difference here, rather than going for x squared minus y squared equals 1, we've changed where the negative sign is. So we've got y squared minus x squared. We're still going to keep the same reference. We're going to keep y and b connected and x and a connected, which means our asymptotes will still be the same, b on ax and minus b on ax, and any translations we have as well. The centre will be the same, but what will change is the position of the hyperbola. So rather than having these positive and negative parts drawn over here, on the right hand side and the left hand side, we'll get an upper part and a lower part as well. Worth noting, I didn't touch on it back here, if a and b are equal, okay, we've seen various cases where an ellipse creates a circle, those particular types of situations, you'll actually get asymptotes that meet at right angles. So if they meet at right angles, we've got a definition for that, there'll be a rectangular hyperbola. So either this form or that form may create a rectangular hyperbola based on these particular values of a and b. You're able to find angles between these particular lines, work back with your linear graphing skills, m equals tan theta, those sort of skills to find angles between asymptotes as well. So that covers this final section of the course. As you can see, circles, which start from an understanding of Pythagoras, moving into ellipses, and finally we look at these hyperbolas, and that pretty much wraps up this early section of the course. We'll come back next with, I think, vectors. Thank you.